let's just get into it. So on today's agenda, we're going to look at the key concepts behind indices. We're going to then look in depth at the multiplication rule, and then in depth at the division rule, and round off as we always do in our exam questions, which I might do in a separate video depending on how long this video gets. So let me just outline a few of the key concepts you're going to need to know before you attempt any sort of question to do with indices. So 5 to the power of 4 is written as 5 times 5 times 5 times 5. So this essentially just means 5 times by itself 4 times. And as you can see, 5 to the power of 4 is 625. The next rule is to do with fractional indices. This basically means, as you can see, 25 to the power of half goes to root 25, which is just 5. So anything to the power of half is just a square root. The same way anything to the power of 1/3 would be cube root. Sorry about that. So yeah, so anything to the power of a third. So if it was 20, if it was 9 to the power of third, it would be the cubed root of 9. Whatever. That obviously doesn't simplify to anything, but okay, yeah. So 8 to the power of 2/3 goes to the cube root of 8, as you can see, because essentially 2/3 is 1/3 times by 2. So we cube root it, the 8, and square it. So we always use the denominator as the cube root or the cube function of the number, and then use the numerator as the square. We times it, yeah, we square it, or we cube it, or we put it to the power of 4 to the power of 5. The next one is to do with multiplication of brackets. So when you have a term in a bracket, in brackets like we do here, we can then square every single term. So obviously 2 squared is pretty self-explanatory, it's 4. And then the a cubed squared, we just times the 2 powers and get a to the power of 6. Hence this simplifies to 4a to the 6th. So anything to the negative power, we first initially flip. So as you can see, 2 to the negative cubed will be equal to 1 over 2 cubed, which is just 1/8, as you know. So essentially when we have a minus, we flip the fraction, put it 1 over, and just get rid of the minus, and yeah. Reciprocal is when you raise something to the -1, and as you can see from the previous example, anything to the -1 is literally just 1 over it. So this x in this case is just a generic representation of a term. Okay, I think that covers all the basic rules that we need to know. Okay, so now looking at the multiplication rule, I've made a mistake in the PowerPoint, but just ignore that. When we have two terms with the same base a in this case, and the operation that we're applying is multiplication, we can simply add the powers. So if we were to apply this to this example, we can see that this term x to the power of 6 and this term x to the power of 2 have the same base x. So what we can do here is we can just add these bases. So we use the same base x, and 6 plus 2 is 8. In this one, same base y, add them together, we get y to the power of 3. This one, similar case, a and a, we get a to the power of 12. Okay. Moving on to the intermediate questions. What we want to do here is treat each term separately and deal with each term separately. So we have 2x cubed, 5x squared. So we want to deal, I always like to think of this as we're going to deal with the numbers first. So in this case, the numbers are 2 and 5. So 2 times 5 is 10. And in this case, we have x cubed times by x squared. So x cubed times by x squared. And as you can see, same base, add the powers, x to the power of 5. So the answer to this question is 10x to the 5. Okay, this is when things start to get a bit more tricky. We want to look at each term individually again. So we want to look at the numbers the same, and the terms that have the same base, and treat them separately as separate instances and then put them together at the end. So in this case, 4 times by 6 is 24. A to the cubed times by a to the 4 is a to the 7. B squared times by b squared is b to the 4. Hence, the final answer is 24 a to the 7 b to the 4. So yeah, let me just make space for the next question. Okay, so 6x to the 5, y to the 2, z cubed. So going back to our rules of uh, indices that we looked at, we can see that so going back to our rules, what we can see is that when we have a term in the bracket, as we do here, what we simply do is just times each term by itself if it's squared, or we just apply the operation of the exponent. So in this case, what we're going to do is we're going to do 6 cubed, which is 216, x5 cubed is x15, and then y to the 6 z cubed. And each term in the exponent we're timesing by this. In this case, z is to the power of z to the 1, because that is just z, and times 1 by 3, that's how we get the z cubed on the end here. 6x5, yep, 5 times 3 is 15, 2 times 3 is 6, that's how we get that. Okay, in the challenge question, we're going to have to apply just our knowledge that we know from before. So in this case, 2x cubed squared is just, we first look at 2 squared, 4. Look at x cubed squared is x to the 6 times by x to the 4. This is going to give us. So firstly, we look at the numbers, and we get 4 times by 1, which is 4. X to the 6 times by x to the 4 is just x to the 10. And that's our answer. Okay. Looking at the division rule, we have a similar sort of concept, and we're just saying when the bases are the same, a and a again, and they're both to the power of different exponents, we then and one's being divided from the other, we can take the common base and just minus one of the powers from the other. So in this case, we can see x and x, same base, 7 minus 4, x to the 4. Same base, 5 minus 2, so a 5 minus 2 is equal to a to the 3. This one, b99 and b76, we divide them, we get b, it's a bit of a difficult one, b23 is that? Yep. Okay. Again, we're going to now follow on to the intermediate and see a similar sort of thing that we saw in the multiplication step, but obviously just this one's division. So we obviously treat the numbers first. 12 divided by 3 is equal to 4. X to the 6 divided by x squared is equal to x to the 4. So 4x to the 4 is our answer. This one, we look at each one individually again. 15 divided by 5, 3. A cubed divided by a2 is just a to the power of 1. So we leave that just as a. And then b4 divided by b cubed is just going to be b to the 1 again. So that's our final answer. Then we look at this one, number 3, 5a to the power of 8 b cubed divided by 10a squared b. We then first look at the numbers. 5 divided by 10 is equal to a half. A to the 8 divided by a to the 2 is equal to a to the 6. B to the 3 divided by b to the 1 is equal to b to the 2. So in this case, we're left with a half a to the 6 b squared. That is our final answer. Hopefully you guys are getting the gist. Okay, yeah, I've just cleared that. It's fine. So looking at the challenge questions, we first apply our rules of uh from multiplication. So in this case, we look at 3 cubed, which is 27, and then x to the 4 cubed is equal to x to the 12, because we just times these together, and the first term ends up as 27x to the 12 divided by x to the 5. Then we look at 27 divided by, in this case, it's 1, so 27. X to the 12 divided by x to the 5 is 27x to the 7. Okay, so in this case, we can just, it's the equivalent of writing 6a 7b cubed divided by 2a squared b to the 6. And what we're going to do here is we're going to treat each one individually and go 6 divided by 2 is 3. A to the 7, let me just do this here. A to the 7 divided by a to the 2 is a to the 5. Put that in here. B to the 3 divided by b to the 6 is equal to b to the negative 3. Put that in here. And that's our final answer.